We'll go to start. All right. So, by the calculus, most of step two, Isaac Newton's. All right. So here we have Isaac Newton. He was born in England in 1643. Yeah. And he is often credited as the absolute father. Okay. The only issue is at the same time, we have this guy over here in Germany named Gottfried Leibniz. Yeah. That's why I ran here. I'm studying the worst there. Uh, so he's born in 1546. And roughly within months of each other, they started publishing papers on calculus. All students should be back in their third hour class. Take. That's a symphony. It's the only real important thing is that when they created it, because they were doing things separately on their own, they used different notation. So if you look over there, we see group notation. You're going to see y prime of x, f prime. Those are more Newton way of writing things. Leibniz really like the dy or dx to represent rate of change. So we're going to use Leibniz notation in some cases, or use some Newton notation. It's just, again, you should know where this came from. I do pretty. So now, most of what we're going to be doing, especially in the very first half, is going to be dealing with different differentiations. Now, derivatives deal with what's called instantaneous rate of change. When we get into that, we do need to understand the difference between what is rate of change and what is instantaneous rate of change. So here we have an example of Mr. Burst. This graph is the distance from his house modeled by the function ut. While riding his bike to the store, he realized he dropped his wallet, and he turned around, finds it, and then finishes riding to the store. You see that from here, and turns around, and then turns back. So, what is the average speed or rate of change? And again, that you remember, speed or rate of change is delta y over delta x. In this case, this would be d of 8 minus d of 0 over 8 minus 0. So again, it's just slow. So in this case, we do actually have values, so we can actually find the average rate of change or its average speed. Here we can pull that. So here we have 0, 0, and we have 8, 1300. So 100 minus 0 over 8 minus 0 gives you 162.5. This is in meters, so meters per minute. You do need to make sure you notate things correctly, especially if you're taking the AP test. And be able to explain some things, because you will, in some cases, have to write out the explanation for your work, like why your outcome, explain your outcome. So, yeah. If we were trying to find this average rate change between the second minute and 6 minutes, we actually don't have values, but the setup would just be 6 minus 2 over 6 minus 2. Just our beats. Yeah. Change between the two. Yeah. So how would you write Z? D of 3 minus 2 over 3 minus 2. All positive. No. We're always positive. Yeah. You can have negative, this is all what? Look, you have negative slopes. Now, is it possible to know how fast it's going at an instant? That's gonna be a key thing we're about a lot. There's a lot instantaneous rate of change. Okay, this is going to be the first, well, chapters 2, 3, 4, well, 3, 4, 5. A good short portion of calculus that this outline is just that insignificant. So, to give an example of how to calculate rate of change, we can choose a close estimate. Again, this is the key word in estimate. So we would want to pick a number really, really close to like this. So we find the 2 minus the 1.99. Oh, 2 minus 1.9. Now, that is not going to give us the exact slope, but it will give us a really good estimate. Now, I'm going to show what that means. Give it in here on the graph. We chose 2, which 2 is right here, and chose the point 1.999, basically right on top of it. We have 2 and 1.999. If we connected those dots, what would we create? Or what does that look like? You know? Angela. Looking for the rate of change, what will we be finding? This, the slope of the angela. All right. Now, to do that, we can actually extend this out a bit to the rate of estimate here. Okay. So from here, it does look like here to here, it goes up one entire unit here. So we'll say that this delta y is 300 because it goes up by 300. And then here to here, that if you look down in this, your x values, they go by what? They go by 2. So delta x would be 2. So what would my rate of change be in this case? Yeah, 150. So we said delta y is 300, delta x is 2. So my rate of change, my instantaneous rate of change, my estimate would be 150 meters per second. Per minute, yes, that's correct. Fine. So yeah, you shouldn't ask questions on that. This is just giving you a very brief introduction. Again, if you've taken pre-cal, you've seen a lot of this already, okay, especially what we're doing next. Now, some parts, some aspects of the AP exam are going to have you explain your outcome. Okay. So we find we have the equation B. C represents the buffalo population of the United States. When T is measured in years after 1800, what would B of 90 represent? 1800, but what specifically would it be in population? U.S. Buffalo, 18. Now, since B, we know that the slope, and slope is the rate of change. This would be the rate of change. Well, let me break it. Sorry, let me break it. Because it's not per rate, so it would be the average rate.
Well, things like that count if I'm not on the OG like there's the one that
It, you have very specific. The average rate of change, US buffalo, from 100 to 1850. And number C can be a little bit tricky because again, we kind of represented that as instantaneous rate of change. Okay, but since it's not a perfect derivative, if I actually do a derivative, that's an estimate of the instantaneous rate of change. So we are going to say that this is estimate of the change in the US in that specific year and that specific year we I think it's the first lesson. It's pretty short. A lot of these are kind of pretty short, quick reviews. Once we start getting things that we haven't seen, we're going to do what's called spot checks, just make sure we're all on the page. So in those cases, we have a page with spot checks, you don't want to grab the phone. You can have phone. So let's look at the next 1.2. Limits again, pre-cal, you guys, last chapter you covered. That should be fair. Limits are read as x approaches a specific value, y or f of x also approaches a specific value. And you look at all these questions, what is x approaching? X approaches 2. All right. Now, looking at each question, what does y approach? What? X approaches 2, f of x approaches every single one. We're not going to talk about continuity today. You guys have talked about continuity before? Okay. So you know what type of continuity the second and third one are? They're the same type. They're the same. Okay, they're both removable. Yeah, it's continuity.
So that one is like what's it called when coefficients for
Piecewise.
Yeah.
Piecewise is the only way to see jumps. This, you'll see this. The third one, the only one where the third one exists is also with a piecewise function. But the middle one is if you have a rational equation, and say we have something like x squared plus 3x plus 2 over x plus 2, which actually may be the equation. No, it's not quite. That would end up just being a linear equation. But still, if you simplify that, x plus 2 would cancel out. Okay, and there, the restriction of x can't be negative 2 would just be removed. You still can't equal negative 2. You would have what's created a whole graph. Again, you are. But the only way to do the third one is if they add a piecewise function that sets at x at 2 giving this value. Again, we'll talk more about that later. You don't have to know that today. This is just understanding concepts and limits. And more of a refresher. Now, in some cases, the limit and the function may exist at the same point. So since we have f of 1 is 2 is 1, both the limit and function are the same value. And that's when we have what's called continuous functions, if the limit and the function. Here, since we don't actually have a value for f of 2, we just say, you can say does not exist, I put D and E. The D and E is perfectly acceptable in the AP exam. In fact, usually that'll be a multiple choice response. You can say undefined if you want. Okay, but that's more writing than D and E. That's why I choose it. And then the third one, you have that piecewise section where we have just wholly separate value for f2, which is 3. And the function just quickly do questions 1 through 8, just to get a little practice in there. Right. Again, for limits, we do need to mention both first. Right. One section, one set of limits. So for as approaching 1, looking right here, the function is approaching negative. It's just the function value, -3. We look for the closed circle, which is limit as x approaching 2, again from the left and right, that gives me 2. At 2 would be 3. At 1 is the only one that does not exist. At -2 and the limit are the same, so we have 2. Limit approaching 0 would be -2, and limit approaching -3 would be 1.
Is it okay to do one if there's no actual values there?
It's a limit.
Approach,
It's approaching. So, see, usually the hard part, people with first learning limits to get into your mindset, it's not what it equals, it's what it's approaching. Number 5. Because there's no closed dot anywhere on here, we don't have a value. We do for 2 and -3, even though they're not the same limit, but there's no closed dot anywhere on it. So you just, it doesn't exist.
Yeah. Well, they say about it, you said that, you know, intelligence,
Number 8 and number 3 are roughly the same kind of question, even though the value doesn't equal. There's a closed or an open dot here. That means the function doesn't exist at that. The function doesn't have the same value. So anyway, it's more about what the limit is approaching versus what the value actually equals. Now, given interpretation of statement. Now again, if you could read the statement, that is the interpretation. Okay, it's the limit as what? X approaches 7 f of x. We just did. Limit does not tell you the value of x. It does not. It just tells you what function is approaching. So, will every case the limit equal the function? No, this is false. Okay. We just saw it in the graph. Okay. In 2 cases where the limit and the function do not have the same value. -3 and 2, right? Yeah. Now, does it mean that every function, the limit doesn't That's also false. Okay, because there are cases where the limit and function, basically, it just depends. That's it, it depends. Now, in most cases, when dealing with most functions that we deal with, will the limit and function always equal each other? Yeah, because most functions we deal with are what's called continuous functions. Usually, the only time you're going to see where a function and limit don't exist are in cases like, say, when we have practical functions, function over another function, all piecewise functions. When you think of any other example, I'll talk about two big ones. All right, that's it. That's the first two lessons. If you want to go ahead and get started on the homework, just go to the section where it starts practice. It is both the practice and test practice. You can, if you want, post the homework on Canvas. Hopefully at this point you know how to scan the PDF file, okay, and post it. Or when you're done to show it, I will have it set up as due tomorrow, but I will not take off points until, well, I basically will accept it until the day of test. Okay, so once we test on it, I'm done with it. Don't worry about it. But don't stress it. I will go ahead and put grades in just to make sure hey, you need to keep up at this point. It's more or less trying to make sure you keep it up, but it's not set in stone until the day of test. Just
It's like,
because I just don't put any points. It's a zero after the test. Okay, yeah.
So the practice and test practice homework.
Test and test. But I said every time we do any work, see what they come up on the AP. Yeah.
What does it do, like notes?
I should shoot that tomorrow.
Are we supposed to be doing both of them?
Well, not really, but I figured since I'm gonna give you guys AP work over the weekend, if you get ahead of day, you can start on the class Friday. So that way, first time we do AP work, we can all finish it when we do it.
the notes for the speech, I thought it was like, notes, the motion, the one. My bad. Of course not.